Prisms and cylinders. So we'll first consider prisms. A prism is a solid that has two congruent and parallel faces. So congruent means basically the same size, same shape. So we have two shapes that are exactly the same and parallel to each other, and then those two parallel and same shapes are joined by a series of parallelograms. So every other side is a parallelogram, bearing in mind that a rectangle is a specific case of a parallelogram. Parallelogram is just a shape in which the opposite sides are quadrilateral in which the opposite sides are parallel, and that's true for a rectangle. So, but generally speaking, they don't have to be rectangles. So if you look at the examples on the bottom here, we have a right rectangular prism, which is where the other sides are rectangles, and an oblique rectangular prism, where the other sides are parallelograms. Both of these are prisms. The key thing about a prism is that it has a constant cross-section. So for each of these three shapes pictured at the bottom here, if I were to make horizontal cuts through these shapes, I would get a constant cross-section. It would be exactly the same shape every time I cut, and that shape would be the same as the shape that I'm seeing on the ends. So as I mentioned, a right prism is a prism in which the congruent faces are vertically above each other, which means that the other sides are all going to be rectangles, and a prism that is not a right prism is called an oblique prism. The prisms are named according to the shape of their base. So here we have two rectangular prisms, a right rectangular prism and an oblique rectangular prism, and also a triangular prism. We could have pentagonal prisms, hexagonal prisms, whatever sort of 2D shape. So the name of the prism is defined by its base shape. The other thing to note is we refer to the shape that forms the constant cross-section as the base quite often. That doesn't, in using the word base, we don't actually mean that shape, it's the shape that's on the bottom. It is just the shape that forms the constant cross-section. So throughout this video, I think I'll refer to the constant cross-section more often, where often we refer to the base of the shape. Similarly, the distance between those two parallel faces that form the ends of the shape, we often refer to as the height, regardless of whether the prism is sitting vertically or lying horizontally. We would often refer to that distance as the height. Okay, so surface area of a prism. So the surface area of any shape is the sum of the areas of all its faces. So the key thing really here is just about being systematic in your approach, and it's quite common for students in finding surface areas to completely miss out a side or to not recognise that they actually have sides that are different. So here in looking at this shape, I can see I've got two congruent triangles on each end, which means I'll just be able to find the area of one and double it. And then I also have three rectangular faces, so I have 5 faces in total. So I want to make sure at the end of the day that I've added up 5 different areas. So the two triangles obviously are the same shape, so we will do 2 times that area. And then the 3 rectangles are each different. And again, this is another really common error, to just sort of jump ahead and think, oh, I've got 3 rectangles, they're all 20 by 8, or they're all 20 by 6. Okay, so let's think about finding the surface area here. So I want to think about each of those 5 sides. So the first thing is that I have 2 triangles. 2 times half times base times height. Now these are right-angled triangles. We can see that indicated in the diagram, which means that if it's a right-angled triangle, we have the base and the height. The base length is 6 and the height is 8. So 2 times half times base times height, so half times 6 times 8, plus, now then we've got 3 different rectangles. The rectangle on the back wall, if you like, has dimensions 20 by 8. So we have 20 times 8 for the area of that rectangle. The rectangle on the bottom has dimensions 20 by 6, so we have 20 by 6 for that rectangle. Plus then we have the sloping rectangle. And now we actually have a missing dimension here that we need to think about. So the hypotenuse of this triangle here, AB, is the missing side length of that rectangle. So we want to think about that triangle. So if we draw that out, So we've got this right angled triangle here, this is 6, this is 8, and it is this length, this hypotenuse length that we're trying to work out. So we know that h squared is equal to 6 squared plus 8 squared, and if we know our Pythagorean triads, we might have already recognised that this is just a multiple of a 3, 4, 5 triangle, so h will be 10, but we can always use Pythagoras to work it out. So 36 plus 64, h squared is 100, so h is indeed 10. Okay, so that third rectangle has dimensions 20 by 10. Okay, so then let's work out each part of these. So this is still the same as you were doing 4 separate calculations across the page. I'm essentially working out each of these 4 things separately. I'm just putting them all together in a nice logical sequence that can be read by someone else. And that's the key thing you need to start to look for. How can I make sure that my working out can be followed by somebody else? It's up to you to show the person marking your work that you know what you're doing, not up to them to have to find the answer amidst a mess of working out. Okay, so we've got 2 times half times 6 times 8. So 2 times a half is 1, 6 eighths are 48. Plus 20 times 8, so that's 160. Plus 20 times 6, that's 120. Plus 20 times 10, so that is 200. So we want to add these together. Again, thinking about grouping where possible, or trying to make life easier, I'd probably add the 48 on last. 200 plus 120 is 320, plus 60 is 380, plus another 100 is 480, then plus 48, 480 plus 48 is 528. And so we have the surface area of the prism. Now units, it's an area and the units are centimetres, so 528 centimetres squared. Okay, volume of a prism. So the volume of a prism is simply found by multiplying the area of the constant cross-section by the perpendicular height or length. So, for example, we would find the area of the base or the constant cross-section and we would multiply by the height or the length that is perpendicular to that. Here we would be finding the area of this triangle on the base, that's the constant cross-section, which means this length here forms the height. The height must be perpendicular to the base. Here we're finding the area of this triangle, which means the height is this length here. Again, here the constant cross-section is this triangle, so the length that is perpendicular to that is this. We tend to refer to it as the height, but it doesn't really matter. It's just about clearly identifying which length is required. Here in this shape, I'm going to need to use this trapezium as the constant cross-section, which will make this length here the height. Here, you've got to imagine which is the shape that if I were to slice anywhere parallel to that shape, anywhere through this solid, would I get the same cross-section. So we're talking about this L shape is the constant cross-section here, and that would mean that that distance there is the height. So volume of a prism is just the area of the base or the constant cross-section multiplied by the perpendicular height. So here we've got 2 examples. We have a triangular prism, so the triangle forms the constant cross-section here. We're going to need to know the area of that. And again, it's a right-angled triangle, which means that its base length is 8 and its height is 8. So the base and the height in a triangle are just have to be at right angles to each other. So you don't need to work out the hypotenuse here and then work out that vertical height of that triangle. You can use the 8 centimetres and the 8 centimetres since they're at right angles. So we're going to need to do volume is going to be the area of that triangle, so half times 8 times 8, and then we're multiplying by the height, which is 5. So 8 eighths are 64, half of 64 is 32, 32 times 5. Now 30 times 5 is 150, and 2 times 5 is 10, so here we have 160. The other way you can do this is to think about 32 times 10 is 320, so 32 times 5 is half of that. Again, this sort of arithmetic needs to be arithmetic that your mind is able to do really efficiently. It's going to be number work that you'll need in your BCE exam, so you want to maintain those skills. Try not to jump to your calculator every time. So the second solid is actually much simpler because we're given the area of the cross-section and therefore the 15 metres is the height. So the volume here is just simply 12 times 15. And again, I can think about this in a number of different ways. I can think of 12 times 10 plus 12 times 5, or I could think of 15 times 10 plus 15 times 2. Either way, I'm going to do the second one. 15 times 10 is 150 plus 15 times 2, which is 30, so we have 180. Units on both of these, so centimetres cubed on the first one and 180 metres cubed on the second one. Okay, so a cylinder can also be thought of in the same way as a prism. Technically, it's not a prism because it fails the condition that all the sides joining the parallel congruent ends should be parallelograms. The curved surface means technically it's not a prism, but for all intents and purposes, we can treat it as a prism with a circular base and a height. Any prism, it's sort of like imagining you've drawn some kind of shape that you've then just stretched out in this case in the vertical direction. Okay, so surface area of a cylinder is a little bit complicated, so we just need to think about it. You've got to think about if you were to unfold a cylinder, what surfaces would you get? So obviously you would have a circle on the top and the bottom, and then the curved surface, if you were to unfold it, would be a rectangle. So let's think about the defining dimensions of the cylinder. So obviously we do need to know about the radius, and we also need to know about the height in order to talk about any cylinder. So this circle at the top here clearly has an area of pi r squared, as does the circle on the bottom. Now if we think about the rectangle clearly, one of its dimensions is the height, same as the height of the cylinder. But this length along here, along the top of this rectangle, what we've got to imagine is that that length curls around to form the circumference of that circle. So it's equivalent to the circumference of the circle, and the circumference of a circle is 2 pi r. So the area of the rectangle here is 2 pi r times h. So that means that our surface area is going to be 2 lots of pi r squared, that's the two circles on the end, plus 2 pi r h. And so we have this formula here. Now I want you to be careful about just remembering this as a rote formula, because sometimes you'll have a cylinder that doesn't have a lid, in which case you don't have two circles, you just have one lot of pi r squared plus 2 pi r h. You might just have a tube with no ends. So you do need to understand how this formula is being constructed in order to use the different parts of it depending on the question that you're dealing with. Alright, so here's an example, a very simple cylinder. Find the surface area of the cylinder, first giving our answer exactly and then to 2 decimal places. So the surface area here, we have both ends. It would usually indicate very clearly if we don't, or the diagram would be, it's clearly a solid cylinder. So we've got 2 lots of pi r squared. That's the two circles on the end. In this case the radius is 5, plus our curved surface, which is 2 pi r h, so 2 pi times the radius, which is 5, and times the height, which is 12. So 2 pi times 25, so that means we have 50 pi, plus 2 pi times 5 times 12, 5 times 12 is 60, so here we have 120 pi, which means all up 170 pi centimetres squared is the exact surface area of this solid. If we type that into our calculator, we find that that is approximately equal to 534.07 centimetres squared. Okay, so volume of a cylinder, like the volume of a prism, it's about thinking about the area of the base shape and then multiplying it by the height. So the volume is going to simply be area of the base, in this case is pi r squared, and we'll be multiplying by the height. And so we get this formula for volume of a cylinder. So thinking about this example, we actually have a large cylinder with a smaller cylinder removed from the middle. So we've got to think about the fact that our volume is going to be the big cylinder minus the smaller cylinder. So the big cylinder, it has a radius of 6 and a height of 10, and the smaller cylinder has a radius of 2 and a height of 10. So the volume of the larger cylinder, remember we're area of the base, pi r squared, multiplied by the height. So pi times 6 squared times 10, take away pi times 2 squared times 10. The other way that you could do this would be to find that shaded area. So just find the area of the top and then multiply that by 10. We'd end up with the same result either way. So here we have 36 pi times 10, so 360 pi, minus 4 pi times 10, so minus 40 pi. So that is 320 pi. Units here are meters cubed. And again, typing that in my calculator, we get that that is approximately 1005.31 meters cubed. For our final example, it's not the volume or the surface area we're trying to find. We're given that quantity and it's one of the other dimensions that we're trying to find. Now there's lots of words and information here in this question, and we just sort of got to decipher what's happening here. So the key thing is it tells us that it's a trapezoidal prism. We have trapezia on either end. So we're going to need to think about, and we're given information about the volume. So we need to come up with an expression for the volume that we can set equal to 300 and then solve for our unknown dimension. So if we think about that trapezium, let me just draw that out. So to find the area of a trapezium, we need the two parallel lengths, which in this case it tells us in the question AB is 6 and DC is 4, and we also need the height. Now the height is what's unknown in this question. Okay, so we know that the volume of this shape is going to be the area of that trapezium, which if we recall our formula is half times A plus B, which is the sum of the lengths of the two parallel sides, so 4 plus 6 in this case, and then times the height, which is what we don't know. And then for volume, we're going to multiply by the length, and we're told that AE is 15. That's the length of this solid. So that is the volume, and that we know is equal to 300. So now we have an equation to solve involving H. Okay, so we've got half times 4 plus 6. 4 plus 6 is 10. Half of that is 5. So we've got 5H times 15 equals 300. So that is 75H equals 300. And so H is 300 divided by 75, which is 4. Our units here are centimetres. This is a height, so it's a length, not an area or a volume, so the units are just centimetres. So in summary, surface area of a prism, simply adding up the surfaces of the areas of all the surfaces. Volume of a prism is the area of the cross section or the base multiplied by the perpendicular height. And a cylinder is basically the same thing. The sum of the areas of the surfaces, so that is 2 circles plus that curved rectangular surface. And then the volume of the cylinder is the area of the base times the height, which in this case is pi r squared times h.